In this video, we're going to solve sample exercise 18. We're given some information. We're told that we have a 2.00 gram strip of zinc metal, and it's placed in a solution which contains 2.50 grams of silver nitrate. So those are our two reactants, and the products that form will be silver and zinc nitrate. So let's take a look using this balanced reaction if we can calculate how many grams of silver may form. So first, let's look at our two reactants. So we're given 2.00 grams of zinc, and we're given 2.50 grams of our silver nitrate. So we know that we always have to convert to moles in a first step. So we know that for 1 mole of zinc, we could look this up on the periodic table, is 65.4 grams. And then we can solve for the molar mass of silver nitrate. So we have 1 silver and 1 nitrogen and 3 oxygens. That will give us 169.8 grams. So now we convert to moles, and then using the balanced equation above, we can see that for every 1 mole of zinc, we can produce 2 moles of silver. And then we just multiply here by the molar mass of silver to get to our mass in grams. So I looked that up, 107.8 on the periodic table. And let me finish this conversion factor here. So again, for every 2 moles now from the balanced equation of silver nitrate, I can make 2 moles of silver. So let's do the first calculation, 2 divided by 65.4, that times 2, and then that times 107.8 would give me about 6.59 grams of silver produced utilizing 2 grams of zinc. And then down here, if I multiply 2.5 times 2, divide that by 169.8, and then divide that by 2, I can find that 1.59 grams of silver would form. So this must be my limiting reactant here, my silver nitrate, because I produce the lesser amount of silver. So this is how many grams of silver we could make using 2 grams of zinc and 2.5 grams of silver nitrate. And even though that's a greater quantity here than the other reactant, that is my limiting reactant. So we could write here silver nitrate. And now using my limiting reactant, I could calculate how many grams of the other product of zinc nitrate would form. And let's do that right now. So we have 2.50 grams of silver nitrate. And then I will use the same conversion factor, the same molar mass as above, the 169.8 grams per 1 mole of silver nitrate. And then from the balanced reaction, for every, let's go back up and look, for every 2 moles of silver nitrate, we can make 1 mole of zinc nitrate. So let's plug in 2 moles of silver nitrate down here. That will cancel with this. And then we could make 1 mole of the zinc nitrates. And so we'll multiply 2.5 and then just divide by 169.8, divide by 2. And we forgot our last conversion factor. We'll multiply by the molar mass of zinc nitrate, which would be 189.4 grams. We can find that from adding 1 mole of zinc and then 1 nitrogen, one or 2 nitrogens, and 6 oxygens because we have NO3 2 in our molecular formula. So this tells me that I could produce 1.39 grams of zinc nitrates. And the last part of this question here asks us how much of our excess reactant will be left at the end of the reaction. So again, we can use our limiting reactant, which is 2.5 grams of the silver nitrate, which we found in the first part of this calculation set. That's converted to moles here by dividing by the molar mass. And then we know that our excess reactant was the zinc in our original calculation. So for every 1 mole of zinc, we can make 2 moles, or we use rather 2 moles of silver nitrate. And if we multiply by our molar mass for zinc, 65.4 grams, we can find that we have 0.48 grams of zinc that were used in our reaction. So again, this is how much was used, but we want how much is left. So if we started with 2.0 grams, we subtract that 0.48 grams that we just found. We can see that about 1.52 grams of zinc is in excess, and that will be remaining after our reaction was complete.